First up is the inner join. Remember the case we were looking at with the salary of the employee and combining the data with the where clause? Well, inner joins are the type of join that we did there. If you have columns that link to a column from another table, you can use an inner join. And over here in the right-hand corner, you can see exactly what an inner join does. What an inner join does is it finds the intersection of two data sets based on a link, and it returns you that subset. Now, I said a lot of words there that are very technical, but let me break it down for you. If table A has 1,000 records and table B has 1,000 records, and we link employee number from table A to employee number from table B, and it's a primary key to a foreign key relationship. Well, if table B only has the salaries or the IDs for approximately 500 of the IDs in table A, well, then the matched is going to be 500 large. You see, the intersection of what you find between A and B depends on what you're trying to link. Employee number to employee number, for instance, we found multiple records. And we also saw that they came back in different orders. So when we do inner joins, we're mapping columns from table A to table B. And the intersection that we find between A and B is what we will show you. Now, here is what we did. We used the where clause to apply a link, a join. But this syntax is familiar from filter. What if I told you that there was a different way of doing this exact same thing? Well, all SQL languages come with a syntax to do joins because joining is such a common practice. Joining is a crux of being able to answer questions across your data. When you have large data sets, well, finding answers to complicated questions, you can't just be working in one table with one slice of the data and then taking that data and then going somewhere. No, you have to be able to take data from one table, take data from another table, and kind of relate them to each other in some way. And so because that is such a common thing, we have a syntax called inner join. Inner join is the exact same thing that we did with our where clause. Okay, so let's break it down. Let's go through it. Over here with our where clause, we could see that in the from, we were selecting from table A and table B, employees and salaries. And in the where clause, we were doing the filter to kind of match employee number to the salary employee number. And then we got our intersection. But if we use the join syntax, it changes slightly. It changes in a good way though. When we do our select, we're selecting the same exact data. And when we do our from, well, here's where the first change comes in. You see, when you do a join, you have to decide what's going to be on the left side and what's going to be on the right side. Meaning, where am I selecting from and what am I trying to join it with? Well, if the question is, I want to have the salaries by employee, then I'm going to select from employees and I'm going to join salaries to it because employees is the main part of the data that I'm trying to get. So deciding what's going to be on the left and what's going to be on the right is always an important question. Where am I selecting from and what am I trying to join to? Now here, what I'm trying to join to is the employee to his salary or her salary. So when I do from employees A, well, here's the syntax. I do an inner join. Same principle as the where clause, but again, we're doing an inner join. And we're saying inner join the table salaries as B. We're not adding salaries as B to the from clause like we did over here. We're not doing this anymore. No. Inner join says, hey, inner join this table to the one in the from clause and give it an alias. Okay, so we know that this is the same as doing the comma salaries as B. Now, how do we do our where clause? Well, there is no where clause on an inner join. When you say inner join, you're saying inner join this table to the one in my from clause. And do it on. So join salaries on employee number. Okay, so how do we read this? Well, we know we're selecting the employee information in the from clause. But when we do an inner join, what we're saying is link this table to this table and do it on the employee number. So over here, you can say what you want to join on. Makes sense? You kind of read it like a sentence. What do I want to join on? I'm joining salaries to employees on the employee number. It's the exact same way to do what we did with the where clause, but it reads more nicely. So the inner join syntax is generally considered a best practice. It is more readable than using the where syntax. It shows you what's being joined. It's great. Now, like I said, the results always come back unsorted. So when you do a join, make sure that you order by the employee number. If we go back to our example here, we could see that when we used our where clause, we weren't getting the data back in the order we expect. See, we have the very first person, but then we go all the way up to 10,005. And so if we do order by a.employee number, suddenly we'll get them back in the right order. This is because you cannot deterministically say how something is going to join. The relational model does not warrant the order of the data. So it is up to the query to sort the data. So that being said, knowing that you have to order your data, especially when you do joins, they kind of go hand in hand. Now, here's a curveball. What if I wanted to know the salary of an employee, but only the ones that led to a new title? You see, people get salary increases year over year, kind of like the percentage base or whatnot, but rarely do you get a salary bump that leads to a promotion in title. So what if we wanted to do that? What if we wanted to know the raises from a promotion using inner joins? Well, we know that employees links to salaries through employee number, but title changes link to salaries through the from date. You see, over here, we're already doing something a bit different. We're combining inner joins. We're selecting from multiple tables. We're adding a third table to the mix. This is a nice curveball for the query. But how would we solve for this? Well, what if I told you that title changes always follow 2 days after the raise? So if title changes always follow 2 days after the raise, we kind of know how to write our query, but it's going to become complex. So right here on the right-hand side, you can see what we're doing. Employees, salaries, titles. And through the inner join, there is going to be a very tiny intersection of data that we match. But how would that look? Well, if we were to select from 3 tables, you can see the query over here. Select a.employee number. We're concatenating the first and last name still. We're getting salary from the salary table. We're getting the title from the title table. And we'll get the from date from the title table so that we know when you were promoted on, what date. So we're joining employees to salaries on the employee number of A. Okay, so that's very simple. We already did this one. We know that we're going to get the salaries. We know that we're going to get each salary for each employee, including all the raises. But now we need to know when there was a title change. So we do a second join. And we're joining the table titles as C. And so now we know that title changes always follow 2 days after a raise. Okay. So first off, each title is linked to an employee number. So we need to make sure that we link the employee number from the title to the employee number that we're trying to find. So the employee number that we're cycling through in employees is the one we're going to link to the title. We need to make sure that we don't link every title to every employee, right? We know this because when we join data, we need to join on something that is known. We know now that we're going to find the salary by the employee and we're going to find the title by the employee. But now here's the curveball. The title change always follows 2 days after the raise. So the on keyword works just the same way as the where clause. So we introduce an and. Okay. So when we introduce an and, it's working the same like it does in a where clause. We're saying, hey, where the employee number in titles is equal to the employee number in employees, find me the title. Okay, so we'll know the title for each salary. Let's try that out. All right, so here we are in Valentina Studio. And we have part of our join over here. What you can see is we're selecting the employee number, the salary, the from date, and the title. And we're taking all of the employees from A. We're joining the salaries on employee number. And now we have titles. So let's go look at the schema of titles. We can see that it has an employee number, which is a key reference. We have a from date that's a key reference. And then we have a title, which is also a key. So interestingly enough, we have a lot of data to join on. Okay, so over here in our query, we're looking at titles. And what we can see here is that if we join A.employee number to C.employee number, what's basically going to happen is we're going to join everything on the employee number. But we're going to get way too much data back because we're not syncing on the unique title. So what you can see here is that we're getting all of the salaries for 10,001. Interesting. And then we can see that we're getting all the salaries for 10,002. Looks okay so far. And then the same for 10,003. But then here we hit 10,004 and we can see that because he has had a title change, now the data starts going wonky. Interesting. Okay, so in 1986, in December, he was an engineer. And then he was also a senior engineer. And then the same in 87? And the same in 88? No. This data isn't making sense. Okay, so you may be thinking to yourself, well, if we looked at the schema, there was a from date. And it was a key. And salaries has a from date that's a key. Okay, so let's join those two to each other. So let's say and B.from date equals C.from date. What will this give us? So when we execute that, what we're going to see now is that we're getting the unique salaries back. Okay, so we're getting the right salaries. We can see that 10,000. But what happened? Weren't people getting incremental raises? What happened here? Well, what I can say is that title changes always happen 2 days after a raise. So how would we go about doing that? So what we see here is basically their starting salary because this is the salary they started with. And if we go to salaries table, we can basically verify this. If we go to the titles table, we can see that they took 10,001 took senior engineer on the 26th. And 10,004 was an engineer on the 12th. And became a senior engineer in 1995 on the 12th. Okay, so we know what their title is supposed to be at a given time. So let's go look at their salaries. So if we look at their salaries, what we can see here is that 10,004 started at 40,000 and went all the way up in 1995 to 60,000. But he went up on the 29th. Yet in the titles table, what we can see here is that his title changed on the 1st of December, but he got his raise on the 29th of November. So 2 days after. Well, luckily we learned a lot of date functions. So if we say b.from date plus interval 2 days, and we equal that, what would we get now? Well, now we're getting all of the employees that ever got a title change. Interesting. Okay, this makes sense. So we're getting the intersection of all of the data for the titles that matched a raise. Good. So these are all the title changes and salaries that were linked to a raise plus title change. If we remove the 2 days, we got their initial salary, their salary that they came in at when they were hired. Also interesting, but that doesn't solve for the particular case we were trying to solve for. This is why we said title changes always follow 2 days after a raise, and that is why we use the interval. Now, what if you want to know the original salary and also the salary at the promotion? Well, let's take a look at that. Well, we know that if you do the and with the interval, we're going to get specifically the raises with a title change. So what if we do and just do this? Will that do it? What's happening here? Seems like we're not getting any data back. Why is that? We have on employee number C, and we have our and statements. So what exactly is happening? Well, it's not really an and, right? Remember, and or not? This is actually more of an or statement. So what we want to do here is we want to say or. We want it to be either equal to the from date or a raise that came 2 days later. So let's execute that. And what we see now is we're getting their salary when they came in, as well as the salary when they got a raise and a title bump. So we've answered that question. We now know both when they were hired what their salary was, and when they got their first promotion, or second promotion, or third promotion, with a title change, what their salary was at that point. So when we do the inner join on titles, we can use the on statement as a where clause, as a way to filter against this subsection. We can narrow down the matched data in the inner join in the on clause. It is the way that we can determine, hey, only match the data when these parameters are met. And so joining data also works as a filter, right? It basically is a filter. We're joining 2 tables, but we're also using it to filter our results a certain way. Only return me data that matches this way. That's how inner joins work. And so if you took the query here and you executed it, what you basically would get is something along these lines. You would get their name, their salary, and when they got a raise, which is basically the exact same thing that we saw happen here. And we can see when they got their title bump. Now, inner joins can become complicated as you add more tables. When you want to combine more data, more tables, more cases, inner joins can become quite difficult. But just remember the principles of always use inner join as a best practice. The on is where you start linking data together. And 99% of the time, I can't say 99% of the time, but most often it's a primary key to a foreign key relationship in which we'll find that sweet subsection of data that is correlated or related in a certain way that can answer a question we're trying to answer. Now, you may be asking yourself, okay, I get the inner join. I get what it's trying to accomplish. But what kind of other joins can I do? Let's take a look at those.